Hello all, I welcome you to the episode 1 of ATV Design Calculations. We will discuss few contents mentioned here, which are 4130 material and its properties, which includes discussion about tensile strength, yield strength and its density to perform linear and non-linear analysis using computer-aided engineering analysis softwares either ANSYS or Inspire or Hypermesh, and theory of symbol bending, which are applied to the design of an ATV frame, and the fundamental principles of bending theory. Moving on to the third point for the assumptions such as vehicle mass, initial velocity and impact duration, which are made for the calculations. An impulse momentum principle, where we calculate the impact of forces experienced by the ATV during various collision scenarios. Moving on to the next slide, 4130 material and its properties. Before discussing 4130 material and its properties, let's see this 4130 is from which steel. 4130 is an American Iron and Steel Institute, a trade association representing the steel industry in the United States. 4130 is a chromoly steel which is having an alloy of chromium and molybdenum. 4130 is a low alloy steel known for its excellent strength and durability, where it can withstand high stresses and is often used in applications that require high tensile strength and yield strength. AISI 1018 is a low carbon steel which is commonly used for the general purpose applications such as machine parts, fasteners and structural components. Moving on to the next slide, the theory of simple bending, which we see most commonly in strength of materials or mechanics of materials, where the material which we take for racing cars for the tubeless space frame chassis may be assumed to be homogeneous and isotropic and perfectly elastic, where this assumption implies that the material has uniform properties throughout, that it behaves elastically under stress, meaning it returns to its original position or shape after the load is removed. The elastic limit now here is exceeded, where the material is not subjected to stresses that would cause permanent deformation or failure. AISI 4130 is a low alloy steel known for its excellent strength and durability, where, as we discussed earlier, it has high withstand stresses and is often used in applications that require high tensile strength and yield strength. It can withstand high stresses and is often used in applications that require high strength and high yield strength, where the impact of force is very higher than the threshold. Moving on to the next slide, the assumptions made to do the ATV calculation. The vehicle mass with the driver, where we consider the gross vehicle weight as 280 kilograms and the initial velocity being applied for the static analysis is 0 meters per second, where we will do this without respect to time. Final velocity is 16.6 meters per second, as the racing vehicle allows only up to 60 kilometers per hour. Moving on to the next slide, we will discuss the impulse momentum principle. The impulse experienced by the vehicle during the impact can be calculated using the change in momentum. As you see, the impulse momentum delta P equal to m into Vf minus Vo, with a final velocity minus initial velocity. This impulse momentum principle equation states that impulse is equal to the product of mass and its velocity and the change in velocity, where the impulse is equals to 280 kilograms into 16.6 meters per second. Plugging the value of mass and velocity, we get the impulse, and the impulse measured in Newton second. Moving on to the next slide, the frontal impact. Frontal collision assumes an impulse duration of 0.15 seconds, where this is the typical value being applied for the static analysis. It is denoted as delta t for the frontal. The average impact force is calculated by dividing the impulse by the duration of impact. Similarly to the rear impact, assumes the impulse duration to be 0.15 seconds, where the impulse duration is denoted by delta terror. And again, the rear impact is 30,986.67 newtons, which was designated from the impulse duration dividing by the force calculated with respect to time. Again, coming back to the side impact, assume the side collision impulse duration as 0.15 seconds and give the boundary conditions, fixed supports for RRH members and SIM members, where RRH stand for rear roll hoop member and SIM stand for side impact member. And with the same side impact member in the opposite direction, apply the force being calculated from the impulse momentum principle. Coming back to the rollover impact analysis, it assumes 0.3 seconds of duration time, where still this delta t is denoted by 0.15 seconds and the front rollover is 15,493.33 newtons. The average impact force is calculated by dividing the impulse by the duration of impact. AISI 4130 is a low alloy steel, as we discussed earlier, where it can often withstand high stresses that require high tensile and yield strength. While AISI 4130 is a steel alloy, is denser than aluminium. It offers a better strength to weight ratio. That means that the same level of strength and durability. The components made from AISI 4130 may be lighter than those of 1018 and AISI 6061. In off-road racing, reducing weight can be the crucial for performance. The material properties involved for 4130 are ultimate tensile strength, which is 560 megapascals, ultimate yield strength, which is 460 megapascals, density, which is 7,850 kilogram per meter cube, Poisson's ratio, which is 0.2 to 0.33. And the common problems associated with the AISI 4130, where it cannot be used for the arc welding metal, where the metal will disappear. As gas tungsten arc welding concentrates more heat on a particular area, the cooling rate is highly unstable in the heat affected zone, where this leads to the deformation of brittle structures in the heat affected zone, and these brittle structures are not desirable, and it can induce crack after cooling. Also, it may lead to the failure in case of accident, where this can be overcome by the chromoly, which needs to be properly heated treated in order to extract all properties from it. Also, the reacting material during the welding is molybdenum due to its high excessive strength, also which exhibits the same properties as a 1010. Thank you all for your kind attention.